Okay, we are live. Okay, 3, 2, 1. Hello, everyone. Welcome to episode 130 of the Security Podcast on the In30 Network. Today, we want to talk about the massive botnet. I think it's called Mirai that hit the dying DNS service on Friday, causing lots of people to either become more productive or curl up in a ball in a fetal position, screaming, I want to send more Slack emoji. So, Tom, what's your favorite Slack emoji?
I've got to say the Space Invader.
Space Invader, not the multicolor thumbs up guy. The guy you could choose your skin color on the thumbs up.
No, I like the Space Invader. It's simple, it's plain, and it conveys a particular feeling.
So before we get into the main topic, I think you sent me my a Bluetooth low energy vulnerability on the tracker, which is a little dongle thing that I have. And I don't think as much as I got a whole bunch of trackers and I don't have positive things to say about them. So find another one. But I thought they were good because Amazon put in a lot of money and has Alexa skills and everything into it. They're not loud enough. Most of the batteries, they did like a production one run, and they're just trying to bleed stock out. So most of the batteries are dead. And now we find out that the Bluetooth is just wide open to anybody, which begs the question, is that a feature or a bug?
Well, they can't. I mean, with the tracker, the idea is that you've got everyone or a bunch of people running the tracker app that's constantly looking for these devices. So they can't obfuscate it too much because the idea is if somebody comes across your keys on the beach, the tracker will connect to their phone and it'll send up a ping ID saying, hey, I found this device ID at this GPS location. There are issues beyond that, but you can't have a fully opaque device. That would defeat the purpose. But there's a bunch of security vulnerabilities that have been reported and are either fixed or being fixed currently.
Just for me, it's one of those, okay, this was the last straw that broke the camel's back. I didn't have too much luck with them. The batteries was dying, all this. And I said, okay, that's it. I'm done. I'm still looking for some sort of device that looks for my keys, but I don't. And I think it's going to end up being Bluetooth low energy, but I don't know. I feel like we need to come up with yet another standard, like just a key finding standard that's quote unquote secure.
My most secure key finding standard currently is PGP key servers. I like. There's also the bowl by the front door where my keys go in. That's pretty secure, seeing as I use a deadbolt. But yeah, I think.
Look, I put the keys in the same bowl that you put your keys in every day.
What? So why do you even have a set of key? Why don't you just generate your keys naturally per connection, per use, right? Just use Diffie-Hellman on your car.
Well, you know what I want? I want some sort of. I do like. Do cars still come with the code that the 4-digit code that you can get into the car with?
I think that's deprecated now.
Because you know what? I'm much better at remembering things than to remember. This is ironic than remembering where I put my keys. But it's always I put it in the bowl, except when I can't find my keys, and that's usually when I'm in a rush. So
yep.
So, and then the problem with the tracker, it's not loud enough to really find it. And when you have your hat and your gloves on and you're trying to push the little thing on your phone or I love it, you push the thing on your phone, then your phone locks. Then you have to take off your glove while it's beeping. So I don't know. I don't know what that answer is, but I like the idea of some little thing that goes on your keychain or your wallet, or you know what? Here is the real use of it. I want to put one in the back pocket of my son's jean pants. So just in case something really bad happens, I can like locate it. He can have a large sound coming out of his rear end instead of paying for these $30 like watches type things that cost monthly and yearly and everything else. So anyway,
you could just strap a Galaxy Nexus to him or put that in his pocket.
Yeah, but you still got to pay the service fee. I want a one-time.
Yeah.
I need like a Raspberry Pi like credit card thing that I can ping. I mean, so I figured Bluetooth Low Energy. This was within 30 feet. It would be good, but anyway. So let's move on to our main story, which is Dyn, DYN Dyn. I guess that's how you pronounce it. Suffered a massive DDoS attack on Friday, and the really cool part is I was talking about DNS to my class unknowingly that this was actually going on. I was explaining to them, hey, do you want to know how you really screw up the internet? All you need to do is send a whole bunch of traffic to one of the 26 DNS servers and keep it down for 24 hours, and you will wipe out DNS. And that's almost what happened. So
Yeah, so the botnet didn't attack the root servers. I know that there have been DDoS attacks against DNS root servers before, and they've weathered the storm. But I didn't even know that Dyn was such a big player in the DNS space. I knew they were big. I knew they were used, but I thought they were more consumer focused. I didn't realize that they were the authoritative name servers for companies like Twitter, Reddit, and a whole bunch of others. They apparently are the authoritative name servers for a lot of big companies.
look, it's one of those things that you don't hear about. Like, who knew that Sprint was the largest mobile? I mean, Sprint has the largest amount of black fiber, I think, of any company right now. And all we know is that they're like the number 4 wireless carrier. But who knew that they were MCI and they just own all these underwater sea cables? So Dyn must be the same idea, where they're just really enterprise and they have this really small forward-facing website that says, "Hey, give us we'll do dynamic DNS for you." That's why I heard of them, nothing else.
Yeah. So we should explain what an authoritative name server is and really what DNS does. DNS is the seemingly magical protocol that turns Google.com, the name of a website, into an IP address that your computer can use to travel along the tubes of the internet, grab that data, and bring it back to you. DNS turns a host name into an IP address. An authoritative name server is the one server that says, I am the rule of law for this particular domain. For Google.com, I am the authoritative name servers. If you want to know anything about Google.com, its subdomains, where the mail gets routed to, anything, you ask me. And DYN was the authoritative domain for a lot of these big companies. So Twitter uses that as their main DNS platform. Any subdomain, all their servers, all their systems, everything that every host name that Twitter publishes to the internet, DYN keeps that information. Now, it's not secret. It's not like they're the only ones that have it. DNS works in a caching mode most of the time, which means when your computer goes out and it asks DYN, hey, could I get the address for Twitter.com? DYN hands it over and says, yeah, here you go. And your computer will keep that. It'll look at what DYN hands it, which is, it says, okay, you asked for Twitter.com. Here's the IP address, but not only that, here's a timer. Here's the time to live for that address. You have 600 seconds before you need to ask me again what this is. What this does is it actually speeds up your browsing. You see, if DNS is slow, if it takes a long time to resolve a name, your browsing feels sluggish. It feels terrible. And that's why after the first time you go to a site, subsequent visits, at least for a short period of time, are actually going to be much faster. Not an incredible amount faster, but it'll feel faster because you don't have to look up the IP address each time. When that time to live expires and the TTL value ticks down to 0, your computer goes, oh, it expired. I'm going to have to go ask again. So it goes out and asks DYN again. That time to live value is configured by the company that uses the DNS servers. It is a user configurable value. And some of these websites had TTL values of seconds. Or a minute in some cases. Very low TTL values, meaning when it expired on your computer, you had to go out and ask DYN. They were being overloaded by not only DDoS attacks, but now they're being overloaded by regular users hitting refresh a bunch, trying to get the IP address of Twitter.com. And they're like, well, I have to hand it out because everyone's TTL expired. and now they're being overloaded by regular users who are not malicious. They're completely genuine traffic, compounding the problem. It was a giant mess.
The question then becomes, well, so why couldn't, I guess they couldn't do this, these websites saying, okay, while we're being attacked, we're going to make the front page of Twitter the actual IP address, or somebody, again, it doesn't help when you don't know anyone's IP address. So they could say, you want your favorite IP addresses? This is where Google is. This is where Reddit is. This is where Twitter is. And I wonder if Google could have done that on their homepage.
There are some people on GitHub, Hacker News, Reddit, and various places along the internet that actually published list of host names and IP addresses. That's called a host file. Before DNS, that's actually how we used to map IP addresses to names, as people, this is the early days, not even, I don't want to call it the internet yet. It was still, an infant at that point.
It was ARPANET.
This is how the ARPANET mapped hosts. You put them in your host file. You said, okay, well, Bob's PC is going to be at 192.168. whatever, and you just listed them sequentially in this text file. And what your computer would do is every time you requested an IP or a host name, it would go to your host file first, grab that IP, and then connect to it. That's still the way it works today. So if you were lucky enough to grab one of these host files, or at least some entries in that host file, you could add that to your computer, and you wouldn't have to look up DNS again. You wouldn't have to look up DNS for twitter.com if you have twitter.com in your host file. Now, the bad thing is, Twitter is a big company, and with a lot of modern web companies, they're constantly shifting stuff around. They're doing multi-stage caching. Depending on where you are geographically, you might get physically different servers located around different parts of the world to make the website faster. So if you bind an IP address like that, you're not going to be using the website as Twitter or Reddit or Google intends. And that can cause a host of issues.
Oh, I was just thinking it reminds me of, if you want another analogy that makes also sense, is remember when you dropped your phone in the toilet and you create a Facebook group that says, I lost my numbers, give me your numbers, and everyone would start putting their numbers there. If you could just aggregate that, it's almost the same thing. The problem is Facebook wasn't down, so Facebook figured this out, but it was, hey, does anybody have the Twitter IP address to get to Twitter? The problem is no one else was getting to Twitter, so it didn't matter because you weren't seeing any tweets. I mean, Twitter was probably quiet for 6 hours.
Yeah, the people who had gotten there and who were using, who had gotten the longer time to live values were able to get to Twitter. So there are some people complaining, there was nothing on Twitter, or certain people couldn't get to Twitter. For some people, they had their DNS caching configured in an odd way. For other people, I know that OpenDNS worked for me during this outage. Google DNS was hammered. I couldn't get anywhere with Google's DNS, but it seems that OpenDNS worked just fine.
So I think we should explain that. So what's the difference between OpenDNS and Google DNS, and why do we care?
So you can, in every router and every operating system, what you can do is you can say, I want to ask this server for my, I want to use this server as my phone book of the internet, as my DNS server, or I want to use these servers, and you give it a couple of them. So Google runs public DNS servers. They're designed to be fast. They're designed to be robust. I love Google's DNS servers. They're great. But there is the privacy implication of, you're using Google as the phone book of the internet, and yes, they are tracking that. OpenDNS, on the other hand, also runs public DNS servers. You don't have to pay to use them. You just put in the IP addresses and they work. But let's say your DNS server that you're currently configured to use is being hammered by a DDoS attack, or it's down, or they had a bad upgrade and the server's on fire, or someone made a stupid routing mistake and you can't get there anymore. Whatever the reason, if you can't get to your configured phone book of the internet, your DNS server, you're not going to be able to resolve any addresses. So at the time, Google's DNS server was being hammered like crazy. I couldn't resolve hardly anything. So I switched to OpenDNS, and the problem seemingly vanished. It was really boggling for a while because Google's DNS is so robust and powerful and amazing, and I've never had issues with it. It was amazing to me that was the cause of my problem at the time. It's very interesting. This botnet was nothing to sneeze at.
I run OpenDNS. So by the way, if you don't know what you're running, you're most likely running your ISP's DNS version, and that's configured on the box, or yeah, it's basically configured on the box.
Or handed out through DHCP. So when you connect and you plug in your router, it does a lot of things. When it gets its IP address, your ISP can say, oh, hey, by the way, here's the DNS servers if you don't have any configured. And your router goes, oh, cool. I've got DNS now.
So most of the time it's through your ISP. If you're nerds like us, you say, hey, you know what? We want to find a faster one or a different one. And there's different reasons. OpenDNS has a whole bunch of features that you can use for parental controls and blocking of malicious content and little things like that. So I switched over to OpenDNS on the router level years ago. You could switch to DNS. I think you could do DNS on your PlayStation 4. Someone said that sometimes you want to put, I don't know why you would ever do this. You could switch DNS on the local computer, but for the most part, you can do DNS on the router level. Your whole house uses it, and OpenDNS has seemed to work fine.
Yeah, and that's one of the big things. If you encounter, slow initial connections to websites, or I know in the case of Time Warner, there's almost a quarterly occurrence of something happening to Time Warner or Comcast DNS servers where they're just not available or overloaded or going through upgrades, and you can't get anywhere on the internet because DNS is one of these backbone cornerstone technologies of the internet. It's so vital to how we use the web today that just nothing works without it. So when Comcast or Time Warner, when they have a DNS outage, the world comes to a halt, at least for the local users who don't know, hey, you should probably just move to Google or OpenDNS.
So when we hear about these countries killing the internet, are they doing something with their state-run DNS? I have a feeling when Turkey was going through its coup, or the Arab Spring years ago, I remember seeing a whole bunch of signs saying, if you want to get to Twitter, put this as your DNS. That must mean that Egypt was killing DNS. They pulled the plug.
In some cases, yes. Now, for these countrywide internet bans, it all depends. They all do something different. Like China's got this giant in and out firewall that controls what gets in and out of China. They could block everything at the stateful packet level. They could search for words and unencrypted traffic. They could block completely encrypted traffic that they can't peer into. For Egypt in particular, I believe it was a DNS level block. So they went to the ISPs and they forced them to block certain websites. And it's not really a block. It's, they take the website address, they take twitter.com, and they either, say the IP address of twitter.com is 127.0.0.1, which is localhost, which is your machine that you're currently on. That's called a loopback address. The computer asks itself. It's basically a way to black hole or to give a null route to certain website addresses. But as we've seen the pictures of the giant sheets and blankets and stuff draped over balconies saying use Google DNS 8.8.8.8 and you'll be able to get to these places. That's the reason. That's how you evade a DNS black hole.
So I didn't use Google DNS for one of those stupid this is a moronic reason. Google already has everything about me, whether Gmail or Google searches or anything else. I just didn't want to have this tracking piece. And I understand that it's stupid, but it was just like, they have everything. I don't need them to see everything I go directly to. This can somehow disintermediate that. And like I said, I know that's stupid, but for the most part, people are saying Google DNS is really fast.
It is. It's great. And it's the default on a lot of things now. I don't have an issue with Google DNS personally. I don't use them, but I don't have an issue with it being configured on some of the servers I run, for instance. But there is that component of, you are asking Google servers for an IP address of a host name. That will be tracked. That will be logged somewhere. They will collect analytics data off of it.
So for me, that was it. My question, this is where my ignorance comes in. Why do we need two DNS servers? Why do they always give you the primary and the secondary? And then I think I saw you or somebody else in our group said you can do OpenDNS for one and the backup being Google DNS.
Yes, you can. How most DNS, and this is not true for everything, but how most DNS is configured today is it's not primary and secondary, believe it or not. When you list DNS servers and you ask for an IP address, when you say, hey, I need to know where google.com or yahoo.com is, you will blast a DNS request out to every single configured DNS server at the same time. And whoever gets you the answer back first is the winner. So if you had, your ISP's DNS and then, Google DNS, OpenDNS, and, something else public configured at the same time, you can have a DNS race and see who can get you the fastest answer, which can speed up browsing. Let's say you had Google DNS and OpenDNS configured at the same time, right? Google's overloaded right now. They're under a DDoS attack. They can't get you the answer, but OpenDNS can, and they hand you the IP address. It's another way to kind of prevent outages if your DNS provider is under attack or they're busy or, you name it. Having backups is a good thing.
So, okay, so we talked about DNS, and if you want help configuring it, get into, here's the time for the plug, our WhatsApp group. Again, message us, message the In30 Twitter or one of us, and we'll get you right in. We can help you configure the DNS for you. I'll just end the DNS conversation with Steve Gibson of Security Now years ago made a DNS benchmark tool. It only runs on Windows. You run it, it's very small, and it will tell you what the best DNS server out of the hundreds that he has configured. And even if you want to roll your own, he'll show you how to roll your own and set it up with your host file and everything else if you choose to. But definitely check it out. He said that he saw a tremendous uptick in traffic based on that, and it will help you find maybe Comcast is the fastest, maybe OpenDNS is the fastest, maybe Google is the fastest, but definitely DNS is a bottleneck if it's constantly looking up and it's being hammered and it's being slow and everything else. So definitely check that out. So you want to talk about the botnet that hit it? The Mirai, is it the Mirai botnet?
Yes. So we've talked a lot about DNS. What is DNS? How it's configured. But why was this on fire, right? It's a backbone technology of the internet. Well, turns out that the Internet of Things has done what we feared what the Internet of Things would do. Cameras and DVRs, mostly from one manufacturer, but there's a smattering of everything in this botnet. We're all attacking at the same time. This is part of the Mirai botnet of Internet of Things devices. It is one of the, if not the largest DDoS attack that we've seen of all time. And it looks like they can just flip a switch and blast anyone they want to off the internet. And because it's distributed, there's not a lot you can do. One person attacking you, you can say, okay, firewall, go ahead and block that IP address. I don't need traffic from that guy. But if it's coming from all over the world, all at the same time, A, if you can get into your firewall's management interface at that point, that's a good sign. And B, you don't know whether that's legitimate traffic, whether that's people getting to your website and browsing Twitter, or if they're attacking Twitter, right? The traffic looks like the same thing depending on what they're asking for. There would be ways to try to prevent this, but the core of the issue is the Internet of Things devices, the no-name white label stuff that you can buy at any place. I'm starting to see stuff, IoT devices in grocery stores now. These devices, they're put out there. They don't have patches. They're not going to get security updates. They're just thrown in a box, pushed out, and they'll connect to the internet and get an IP address. And in some cases, they'll use UPnP. They'll make a public port, on your router at home, and let malware come in and do whatever it wants to it. In particular, these devices were hard-coded with really terrible default passwords and remote management accessible from the internet. So scan the internet, you figure out, okay, these logins work on these devices, and now you have an instant botnet. Unfortunately, I think this is going to get worse before it gets better. All hope is not lost. The world's not coming to an end, but we need to start taking a real hard look at what will we buy, right? What are we plugging into our home network, and is it worth it? Is the benefit worth the risk of running a device that may or may not get updates in the future?
The problem is, you see a pretty website, and I'm on Facebook, and I get a lot of Internet of things to say, do this, do that. And it has a really spiffy website. It says military grade encryption at the bottom. It says all these other things. It just says a whole bunch of things that the average person won't understand. And then there's no way to secure them. And if there's an update, we don't get it. Like we said, with this tracker Bluetooth low energy vulnerability, this will probably never be updated. They're not going to do a recall on these devices. They're just going to say, whatever, you buy more. But I don't want to buy more. So you can see that all these things that we're finding out have these little radios in them. They're connecting, and nobody's updating it. Somebody's finding a vulnerability in the toaster and then saying, oops, oh well. And you know what? It was a lot of people on Twitter said, you want to stop the DDoS attack? Unplug your toaster. And the question then becomes, why are all these things going online? And should we be able to, I don't know, disconnect them? That was one of the topics that was discussed. Should we be allowed to reach in and disconnect these devices? So I'm ready for Congress to hear all about this soon.
They will. And this gets into a bunch of legal gray area. Currently, under current U.S. law, there's a computer, it's sending out malicious traffic. You can prove beyond a reasonable doubt that it has malware and it is causing havoc for someone somewhere. It's being used as a proxy. It's part of a botnet. It's sending out nasty traffic. It's actively executing attacks on other websites, and it's trying to propagate. By U.S. law, you cannot, even if you have a clear way to hack into that machine, you cannot hack into that machine, and you certainly can't disrupt the operation of that machine. Currently, that's a felony. That's the Computer Fraud and Abuse Act. The law is written in such an open way that even doing something for the good of the people would be illegal. And I totally get it. I totally get it. We probably don't want to write a law that says, hey, if we think something's bad, we can go in and shut it off, right? Because we would all rush to the nearest website that we all hated, and we would say, yeah, well, we're going to hack this and shut it off because it's bad and we're doing a public service. Yeah, we probably shouldn't operate that way, right? The internet is a free speech zone. But in cases like this, if we have the opportunity to stop a botnet, should we? Right? Morally, I think we should, but then again, illegally, on paper, how do you define botnet? How do you define unwanted traffic? It's kind of like the laws regarding obscenity for things that are obscene in public, right? The law basically amounts to, on paper, we don't have a definition, but people know something is obscene when they see it, which is a pretty solid definition. You've got some play there. But, a botnet, we're not going to define it, but we know a botnet, we know a DDoS-capable device, or a series of devices when we see them. It'll be interesting legally how this all shakes out.
Just remember the age of Congress and what their knowledge of all this stuff is. So,
yeah, the main issue and the thing that's going to be really hard to fix is this is only possible because we don't have informed consumers. And that's not, I'm not blaming the consumers, right? They see a thing that'll solve a problem, or it'll be a feature, it will help them in some way, and they paid for it and they put it in their home and they plugged it in and turned it on, right? I'm not blaming the consumer. What I am blaming is we don't have a body out there that says, these devices will get security upgrades. They're hardened. We've tested them. We've had people do black box pen testing and white box pen testing. We have done A, B, C, and D to make sure that these devices won't become a problem for at least the next 2 years. Microsoft just put out their their recommended IoT list. It's something where they basically stamped a Microsoft seal of approval on certain IoT devices, which is great. But I think we need a big, independent body researching these things, and for there to be, not a seal of approval, but you go to a website and you say, well, I need new light bulbs. Who's got the best, safest light bulbs that I know are going to be up 2 years? Oh, look, here's company X selling product Y for price Z. That's great. And it's on this website. I know it's approved. I'm going to be safe. And I'm not going to hurt the rest of the world by buying the internet toaster that attacks Twitter.
The problem is that now we're getting into which is the right certification standard. And
right.
It's so, hey, Tom, I got a good business. I have a good business idea.
The devil is in the details here.
Yeah. So we're going to make our own internet thing certification business, and it's approved by Norton antivirus at the bottom.
It's going to have my face. My face is the seal of approval.
Yeah. So anyway, with that said, we are over our time. I'm going to end it now, and we're going to be on and off for the next few weeks, but we'll be around. Follow us on Twitter, and we're here. We're not going anywhere. We'll see you guys soon. Bye.
See you, everyone.